a more complicated version of inequalities to be discussed in section 1.7 here is the concept of using compound inequalities. And here I use this, the y here, but we're talking about all kinds of compound inequalities right here. So now we already discussed what it means by being a compound inequalities in class. So here once again, allow me to jump directly into the examples here. So the type of compound inequalities, the first type of compound inequality we're looking at here is we have something like this. We have three sides compound inequality. So we have, let's say trying to solve and graph. Let's learn to solve and graph. But then the inequality I have is x plus 5 less than 11 and at the same time greater than 7. So you heard my words. What I say here is logically I want x plus 5 is at the same time less than 11 but and greater than 7. So I need to find an x that satisfies the two sides here altogether. Okay, so now the inequality all of a sudden grows to having three sides. However, it's okay. The way of solving that is just try to take it as simple as those that we've had in the linear inequalities. The only thing that different is we always try to keep the x in the middle term, and we already discussed this in class. So to solve, and the rest is carried out just like how you solve those linear inequalities. So here in this one here, to solve for that, I need to subtract 5 from all sides. Okay? And that's going to get me x less than the right hand side here is going to get me just 6, and on the left hand side, the far left hand side is going to get me 2. Okay? And the inequalities, once again, all of those basic properties of inequality still remain the same. So here, the logical solution here is that to find an x satisfying this long inequality here, this compound inequality where x plus 5 has to be greater than 7 and at the same time less than 11, the only values for x satisfying that inequality here is going to be x anywhere in between 2 and 6. And that's how we can find the inequality, the solution of the inequality. So now, start getting into graphing the inequality. Once again, still draw for yourself the 2 lines of number. Okay, 2 lines of number. And here, look at the inequality. Now, there's this type of inequalities here. There's always has to be like a lower bound, like the lower limits, and think about the 6 here as the upper limit. So you're going to draw the 2 numbers here, 2 and 6, and make sure you put them in increasing order from the left to the right. So I'm putting my lower limits here on the left, and my upper limits on the 2, which makes sense with the way how the line of numbers work. And so 2 is there, 6 here. Now I want x greater than 2, so of course it's to the right hand side of 2. But I want x at the same time those value of x has to be less than 6, so it's only to the left side of 6. So here I'm talking about the shading in between 2 and 6. Okay. Just in between 2 and 6. So now, talking about the 2 ands right here, what kind of, am I going to be using parentheses or brackets here? It all depends on these inequality once again. Now here on the side of the 2, the inequality here appears to be without the equal sign. So I'm using brackets again. I'm using parentheses again. And so I'm using parentheses. And of course, my parentheses always point toward, my parentheses always closing toward the shaded area indicating inclusion, the concept of inclusion. And then on the side of 6, once again, the inequality here is without the equal sign, so I'm going to use parentheses on 6 again. And always the parentheses or brackets, doesn't matter, they always point toward the shaded area. So that's how I graph my solution of the first inequality. And then expressing this here, this final solution here in terms of interval notations. What I have here is I create for myself an interval in between 2 and 6. So I have 2 comma 6 and I have parentheses on the 2 sides, just like whatever the line here is indicating. That's my interval notation. So let's try it again. In example number 2, we want to graph, solve, and graph. We would like to solve and graph a compound inequality. And here I have 4x minus 3 greater than or equals to 3, but at the same time, I want it to be less than or equals to 19. And once again, keep in mind the goal to solve these inequalities here is I always want to finally keep my x always in the middle side and leaving just numbers on the two far sides, on the two ending sides here. So in this inequality, starting out x already in the middle side, so that is a good thing. All I have to do now is add 3, but not just to both sides, to all sides. So I'm adding 3 to all the 3 sides here, and that gets me 4x less than or equals to 22 and greater than or equals to 6. And now to solve for x, all I have to do is just simply divide all sides by 4, and that gets me x less than or equals to 22 over 4 and greater than or equals to 6 over 4. And of course, you can see that in terms of real comparison, 6 over 4 is less than 22 over 4. And so now, that is my logical solutions. And by the way, you can also simplify the two final fractions here a little further. So basically, x is less than or equals to 11 over 2, and here x greater than or equals to 3 over 2. So now graphing my inequality, the solution of my inequality. Once again, here's your lower limits, here's your upper limits. You just simply throw the two numbers here, increasing order from the left to the right. So 3 over 2 on the left, 11 over 2 on the right, whichever one is the larger one that goes to the right. Okay, and here's the inequality here indicating actually in between the two limits here. So I'm gonna shade the area in between the two lines, and this time, now on the left end right here, do I want to use brackets or parentheses? The inequality here does involve the equal sign, so I am using brackets. How about on the right end? Now, do I want to use parentheses or brackets? If you look back at the inequality, it does say that we use equal signs. So we do have equal sign involved. So the inequality here is, that side here is on that closing end, it's brackets again. So that's how you graph the solution of this inequality, of that compound inequality. And the last thing here is to once again rewrite that interval notation, that solution here in interval notation. So the line is telling it, the graph is telling it all. You have an interval, lower limits, 3 over 2, higher limits, upper limits, 11 over 2, and here's the interval. That's how you can just simply translate from the graph into the interval notation. Example number 3, once again showing you how to get around with these inequalities, compound inequality. We once again have to solve and graph the solutions. It's the purpose of these exercises here is to get you really comfortable with solving the compound inequalities. And so I have 1/2 x minus 4 less than -3 greater than or equals to -6 fraction. I do not like fraction, but once again, if you don't like it, you need to find your way to clear it away. Okay, and then it looks like 2 here is one of the denominators. We have denominator 1, a lot of denominator 1s, and then there's one denominator 2 here. So my LCD in this case will be a 2. Okay. And then once you've found the LCD, which is a positive 2, you need to multiply that LCD to all the terms throughout the 3 sides of this compound inequality, and keeping the x in the middle once again. So now what I need to do, on the far left side, 2 times -6 less than or equals to 2 times 1/2 x minus 2 times 4 less than 2 times -3. And once again, notice, as I multiply the 2 throughout all the terms, I don't need to change my inequality anywhere at all. It's just because my multiplier, the number that I multiply, is already a positive number. So I do not have to worry about changing my inequality, switching my inequality. And so what I can do now, just simply cancel the fractions away, can't clear the denominators away. On the far left side, I have a negative 12, less than or equals 2, and the 2 here gets canceled, so I just simply have an x. Minus 8, less than negative 6. Okay, and so now, with this final compound inequality right here, to solve it, it's quite simple now. Adding 8 through all sides of the inequality, and that gives me x in the middle, less than 2 strictly, and greater than or equals to negative 4. That's greater than or equals to negative 4. And so once again, this is my logical solutions. The only x that makes it, the only x values that make this inequality work are those x values that are falling in between negative 4 and 2. So now, to graph the solutions, once again, here's your lower end, here's your upper end. You're always going to need to throw those two numbers on a line. The higher number goes on the right-hand side, and the lower number goes on the left-hand side. So here's negative 4 is the left. The lower number, 2 is the higher number. You want to shape things in between, of course. But now, how about the left end right here, the lower end? Do I want to include negative 4? The answer came with the final inequality comes with the equal sign in that inequality on the side of negative 4, so it comes with brackets. So this thing here has brackets. Now, the inequality on the two side is without the equal sign, so I need parentheses here. So that's how I draw my graph. That's how I graph my solutions, and translating that graph into an interval notation. What I have is the lower end, the higher end, brackets on the lower end, parentheses on the higher end. And there's a comma between the two ends, and that's how you get your interval notation. And that's how you express your final solution in interval notation.